Hi everyone. In attempt to help us through Unit 6, we need to go over a little bit of a prerequisite so that this chapter makes a little bit more sense going into it. So today we're going to start off by writing our outcome, and that is I will be able to simplify, multiply, and rationalize the denominator or denominators of radical expressions. I'll give you a second to write that down. Okay. Make sure you write your name in the top right corner, okay? Whatever date that you are writing this down on and whatever class period you're in. So our essential question for today is, how can I simplify an expression that looks like 4 over the square root of 12? This is something we haven't talked about at all this year. So today we are going to work on that a little bit. A radical, and this is a symbol for it, is a symbol that is used to indicate square roots or nth roots. We really don't care about nth roots right now. For this unit, we're just caring about square roots. Let's label what these things mean. So right here is our radical symbol. This 10 that's underneath the radical is called a radicand. And the 4 that's on the outside, that's not always going to be there. Sometimes it's 1, sometimes it's 2, whatever. That 4 is the coefficient. Or just the number that it's being multiplied by. So let's get right to it. So, simplifying radicals. Our first step is to simplify each radical below. So, the square root of 72. We could put that in our calculator and we would get a decimal. And that's not really what we're looking for here. And there are a couple of ways to start this. My first thinking would be to rewrite 72 into a couple of factors that make more sense to me. There's so many things that you can start off with. The simplest one is if you figure out that 2 times 36 will give me 72. Why is that simplest? Well, 36 is a perfect square. And if I can rewrite 72 into a perfect square and another number, that makes my life easier because the square root of 36 is 6. So I can rewrite this as the square root of 36, which is 6. And I don't know what the square root of 2 is, so it's just 6 root 2. I am going to show you a slightly different way of doing it so that you have choices. Another way is to rewrite 72 into its factors. So I'm going to create a factor tree. And 72 can be written as, well, let's try something else instead of 2 and 36. Let's try 8 and 9, for example. So 8 times 9 is 72. Now I cut these up into smaller pieces as well. So 9 times, or what times what gives me 9? Well, that's 3 and 3. Then we can break 8 up into 2 times 4. But 4 can also be broken up into 2 times 2. So let's look at the final pieces that we have. So we have a 2, a 2, a 2, a 3, and a 3. And I'm going to look for my twins. So we have a pair of twins here. We have a pair of twins here. So I'm going to rewrite that as, if I see a pair, I can bring it out. So my pair, I can bring out 1, 2. I'm going to write that up here. I have a pair of twins here, so I'm going to write that as 3. And this lonely little 2 up here in this corner, that has to stay underneath the radical. And we're going to get to multiplying later, but 2 times 3, we know that's 6, and that also gives me 6 root 2. So either way, you can do it either way you want to. It's up to you. Whatever's easiest for you. Now sometimes, like in number 2, that cannot be simplified, because if I rewrite this in my factor, so let's write this out. I'm going to write 42, and let's get this out. So 7 times 6 gives me 42. Well, 6 can be broken down a little bit easier into 7 times 2 times 3. I don't see any pairs here. There's nothing that's going to be joined in with another one, and that means I'm not going to be able to simplify this. So this one cannot be simplified. Let's try 3 and 4, and then we're going to move on. So 45, I'm going to write as 9 times 5. If you want to write that out a little bit simpler, we can write that as 3 times 3 times 5. I see a pair, 3 and 3. I'm going to bring one of those out in front, because the square root of 9 is 3. So we can skip right to here if you want to. And then that poor 5 is left all alone underneath the radical. And number 4. I'm going to rewrite that as the square root of 2 times 7. Well, I can't simplify 2 or 7 any further, so this one cannot be simplified either. So it can't be simplified. We already multiplied a little bit already, but I'm going to show you how to multiply 2 radicals. So multiplying radicals, multiply each radical below and then simplify. And that should say if possible, but you can't always. When you're multiplying 2 radicals together, you're going to multiply what's underneath there. So you're multiplying the radicands. So 5 times 6 is 30, so the square root of 5 times the square root of 6 is the square root of 30. As simple as that. Number 2, same thing, I'm multiplying the radicands together, so these two. That'll give me the square root of 12, because 2 times 6 is 12. And then you multiply the number that's on the outside, so the coefficients. So I'm multiplying 9 times 5, and 9 times 5 is 45, and that goes out front. Now there are situations, like number 2, for example, where you can simplify it a little bit further, which is why it says then simplify. So I'm going to write the 45 out in front again, but 12, I can rewrite that as 4 times 3. What's the square root of 4? 2. So we have 45 times 2, because that comes out now, radical 3. Last step, multiply the 2 things that are right out in front here. So 45 times 2 is 90. We get 90 square root of 3. Okay, we have a couple more things to talk about, and then we're done for today. So on the next page, we have, or on the back page I should say, we have rationalizing the denominator. And that means eliminating all of the irrational numbers from the denominator. So whenever you see a radical in the denominator, that's not allowed. We have to get rid of it. Let me zoom this in a little bit. Oh, not going to work today. Okay, so 4 over the square root of 10. We can't have the square root of 10 in the denominator. So what I can do is multiply by a form of 1. Which means I'm going to take the square root of 10, multiply the numerator, and multiply the denominator by the square root of 10. What does that do for us? Well, let's use what we know about multiplying. So 4 square root of 10 is in the numerator. This 4 is not underneath a radical. I can't combine 4 and 10. Over, well, when I multiply two radicals together, I multiply what's underneath. So it's the square root of 100. Well, 4 root 10 is still where it's at, but the square root of 100 is just 10. Your last step is to simplify your fraction. So 4 over 10, that if you reduce that, it is 2 root 10 over 5, because 4 over 10 is 2 over 5 if you reduce the fraction. Number 2 is more challenging. So there are multiple ways you could approach number 2, and I'm going to show you one way that's easier in my opinion. So the first thing that I would do is try and simplify what's already here. So we have 5 over the square root of 125. We're going to have to rationalize the denominator. So if I rationalize the denominator, I can before I do that, I'm going to simplify what's under the radical. So we have 5 over, and I'm going to rewrite 125 as factors. And I know that I can write this as 5 times 5 times 5. I'm looking for my twins, so I see a set of 5 here. So that's going to come out in front. I still have a lonely 5 right here, and a lonely 5 up top. I see something that can cancel off. 5 divided by 5 is 1, so those two things cancel, and I'm left with 1 over the square root of 5. We still have to rationalize the denominator, but now it's a lot simpler than it would have been before. So rationalizing means I'm multiplying by my form of 1. I'm multiplying by the square root of 5 over the square root of 5. So we get 5 times 5 is 25, the square root of 25. And 1 times the square root of 5 is just the square root of 5. Last step. What's the square root of 25? 5. So we have square root of 5 over 5. And that is my final answer. We don't have any radicals in the denominator, so we don't have anything to worry about. One last one, and then I want you to practice the problems that are at the bottom. Same first step here. I am going to rationalize the denominator. So that means multiplying, and I should have put a multiply sign instead of an equal sign, by the square root of 8 over the square root of 8, because anything over itself is 1. The square root of 3 times the square root of 8, it means 3 times 8, 24, over 8 times 8, which is 64. Square root of 24 stays in the numerator, but in my denominator, I end up with 8 because the square root of 64 is 8. Now I just have to simplify as best as I can. So the square root of 24, I can rewrite that as the square root of 4 times 6 over 8, because I know 4 is a perfect square. So 4 times 6 is 24. I can rewrite 4 as just 2 because the square root of 4 is 2. So 2. The 6 is all by its lonesome. And then 8 is in the denominator. Final step. Simplify this into 1/4. So I get an answer of the square root of 6 over 4. There are a whole bunch of problems for you to try, A through F at the bottom. And then I really want you to go back to our first page, the front of this paper, and answer the essential question. So how can I simplify an expression that looks like 4 over the square root of 12? Answer that in your summary, and I want you to summarize how you would do each of these things. So how would you multiply? How would you simplify the radical expression? And more importantly, how would you simplify an expression 4 over the square root of 12? If you're watching this at home, bring it to me next class. Otherwise, we're going to work on it in class today. All right, thanks guys.